Hello everyone, my name is Pearl Mukoro and this is my Teach One on question 5 in the subject risk assessment. So this is our question. Calculate the receiver operative characteristic curve associated with predicting from age whether the patient will live or die. The data does not provide a predictive value, but you can construct a prediction based on age exceeding the cutoff value. If the patient's age exceeds the cutoff value, then we would predict that the patient will die. For example, the cutoff values for ages provided can be 40, 50, 60, 70, 80, 90. If we take the cutoff value 60, then we predict that all patients above 60 will die and all patients below 60 will live. Calculate the sensitivity and specificity for all cutoffs. Then draw the ROC curve and find out at what age cutoff of the sum of the sensitivity and specificity are at its maximum. So, for a bit of background, we want to know what is a receiver operating curve. So ROC curves are frequently used to show in a graphical way the connection or trade-off between clinical sensitivity and specificity for every possible cutoff for a test or a combination of tests. The area under the ROC curve gives an idea about the benefit of using the test in question, basically showing us how accurate our test is. In a receiver operating curve, we would plot our sensitivity as the y-coordinate versus 1 minus specificity as our x-coordinate. So this is basically plotting our true positives against our true positives against our false positives. So, sensitivity is the ability of a test to correctly identify people who have a disease or a true positive rate. Whereas specificity is the ability of a test to correctly identify patients who do not have the disease. This is a true negative rate. So the accuracy of a predictive model is reported by repeatedly examining these two things, sensitivity and specificity, at various cutoff levels. So specificity is calculated as our true negative divided by the true condition absent, which is our dead patients in this case. And sensitivity will be calculated as our true positive divided by true conditions present, which is our alive patients in this instance. So going back to our table in question, we will need to calculate the specificity and sensitivity based on the cutoff ages seen here. There are different ranges where we have different alive and dead patients, 45, 55, 65, 75, and 85. So we will derive a cutoff value and use those values to calculate sensitivity and specificity. So in Excel, we will type our cutoff values. I used 40, 50, 60, 70, 80, and 90. So the first thing I did was to calculate the specificity and the sensitivity at a cutoff of 40. So at a cutoff of 40, we would predict that all our patients will be alive, which means that we have no true negative rate. So this value would be 0. So we would divide this value 0 by our total to get our specificity. And on the other hand, sensitivity at a cutoff of 40 means that all our patients were correctly predicted to die from our total, which is 63 dead patients. We would divide this sum, 63, over our dead patients to get our specificity. So just reiterating what I said in the previous slide, we calculated the specificity and sensitivity of our values at a cutoff of 40. So our sensitivity in this case is going to be us looking at the patients in the alive column. It's because our cutoff is 40, we do not reach any level in the age range. We don't reach up to 45. Therefore, our total would be 0, and we divide this 0 by 143 to get the sensitivity. On the other hand, because our cutoff is 40, this means that everything in the dead column becomes true because this is our true condition in the case of specificity. So we divide the sum of our dead column 3 and 5 and 7 and 15 and 33 divided by the total 63 to get our specificity. So we're moving on to calculating the specificity and sensitivity at a cutoff of 50. So at a cutoff of 50, we would predict that 33 alive patients will live. We're going to divide 33 over 143 to get our specificity. However, sensitivity at a cutoff of 50 means that 60 patients were correctly predicted from a total of 63 dead patients. We will divide the sum of dead patients, 60, over our total, 63, to get our specificity. And the table below shows the calculated values. So to visually highlight what I explained, at a cutoff of 50, this means that we have correctly predicted that 33 patients out of 143 patients will be alive. And in the case of specificity, we have correctly predicted that 60 out of 63 patients will be dead. That leaves in the alive column, the age range is 55 to 85, and in our dead column, the age range 45. So following this formula, we then complete the rest of our calculations in Excel to create this resulting table. And we need to calculate 1 minus specificity because we are going to plot sensitivity against 1 minus specificity. And these are the results. So this is our resulting receiver operative chart on Excel, where we have plotted the sensitivity against 1 minus specificity. This is the resulting curve. And in order to check the accuracy, we can perform more tests like determining the area under the curve. And that is it for my Teach 1. I hope I explained it sufficiently for you to finish and understand the question. Thank you very much, and good luck on the rest of the questions.